Hello everyone, and welcome to this new tutorial about FANTASIA. In this tutorial, I will be telling you how you can import Bayesian networks in Unreal and how you can use them with blueprints in order to control a conversational agent. First of all, let's see how we can design and save a Bayesian network with Agrum. Agrum comes with a Python wrapper that's called pyagrum, which is very convenient for designing and testing Bayesian networks before importing them inside Unreal. You can use a Python notebook like this one to design your network, see how it is organized. You can inspect its internal probability distributions, etc. The notebook that I'm showing you is based on one of the first tutorials from pyagrum that you can find on their website. And as I told you last time, the water sprinkler Bayesian network is also one of the classic, maybe the classic example that is used to show how Bayesian networks work. In general, you can fill the probability distributions inside pyagrum. As you can see, you can take a Bayesian network, you can specify the variable that you're going to fill in, you specify if they're present the combination of values of the parents that you are considering and the corresponding probability distributions, just like we saw in the last video. In order to make inference about the Bayesian network, in pyagrum you need an inference engine. In this case, we are using a lazy propagation engine. Inference engines allow us to compute the posterior probability of the variables in the network, so the probability distributions after evidence has been collected, and they also allow us to compute the entropy of the nodes. In this case, we still don't have any evidence about the Bayesian network, so if we print the entropy of the nodes in the network, you can see that we don't have zeros, so nothing is certain. And we can also see the situation here graphically. Now, following the approach from last time, we would like to select the most entropic node among the available ones. So we see it's R. Suppose we ask about R, we collect evidence about R, and we observe that R is 1. R is true. So we add evidence to the inference engine that R is 1. We compute the entropy again, and as you can see, the entropy of R is 0 because we collected the hard evidence about R, and we are absolutely certain that R is 1, so no uncertainty here. As you can see, just like in the last video, all the distributions are updated. We can go further, keep adding evidence and plotting results. We can use pyagrum to design and test our Bayesian network. Most importantly, we can use pyagrum to save the Bayesian network once we're happy with it using the BIF format. Through Fantasia, you're able to import BIF files inside Unreal as Unreal assets. So now let's jump into Unreal and see how we can use Bayesian networks in the engine. Here's the new version of JSON. As you can see, JSON is not anymore represented using a Genesis 8 character. He's now a meta-human. And as you will see, Fantasia has no problem working with meta-humans. Here you can see that we have a sprinkler asset that is a Bayesian network. To import the sprinkler in Unreal, you just have to follow the usual steps. So for example, you go inside here in the Explorer, and you drag and drop the Bayesian network in BIF format inside Unreal, and it gets imported. I'll delete this one as I already set up the project so that I can walk you through it. If you open the Bayesian network, you will see that it contains the variables of the network with the possible values that they can have and the corresponding probability distributions. If present, you can also see the parents of the nodes that you're considering. This is just for inspection. Maybe in the future I will try to design a tool inside Unreal to actually design Bayesian networks, but for now we'll work with this. To use Bayesian networks with JSON, we go inside the blueprint that I prepared on the basis of the one that we use for our basic tutorials. First of all, we need to load the Bayesian network inside the blueprint. So we have a variable here, Bayesian network, is of type Bayesian network. You can create such a variable with the standard procedure. Through Fantasia, you will have a Bayesian network type, object type, inside the blueprints, and you can get a reference to it. You can assign the sprinkler Bayesian network to this variable in order to be able to use it. You don't have to forget to initialize the Bayesian network before actually using it, otherwise you'll get an error. Once you have initialized the Bayesian network, you can start using it. In this example, I will replicate what we've been doing in the previous video and what we just summarized by looking at pyagrum. We want to get variables to investigate, first of all, variables inside the Bayesian network, and we want to produce sentences, questions, that allow us to collect evidence about the variables. So in this function generate sentence that I created, the main logic is contained. So let's jump into it. In this function, we start from the Bayesian network, and with this Bayesian network, first of all, we make inference. So we calculate a posteriori probabilities in the network on the basis of the collected evidence. In this case, we still don't have evidence. The first thing that we do is to check if the entropy of the W variable, so if the grass is wet, is low enough in order for us to take a stance about it. So we check if the entropy of the W variable is higher than 0.1, and if it's lower, so this is false, we take the most probable stance about W. So we get the a posteriori distribution of W, and it's returned as a map of strings onto float variables, values, sorry. What we do here is to check whether the 1 value probability is higher than the 0.1. So in this case, the grass will be wet, and we output the according sentence. Otherwise, the grass will be dry is the correct sentence for our agent to say. So this is what happens when we are sure about the value of W. But what happens if the entropy is still not low enough? Then we need to collect evidence about the variables inside the Bayesian network. In this case, we have a local variable here containing a list, an array, of all the variables in the network. This is just to simplify, but it will do for our case. For each of these variables, we get their entropy and we try to detect which one has the maximum value. So we update a max variable every time that we find an entropy value that is higher than the last maximum that we saw, and max is initialized up to 0, of course. Every time we find a new maximum, we select that variable for inspection, and we also access the sentences map, mapping variables onto questions, so that we know which variable we are investigating, and we also know which question is the one corresponding to the problem of investigating these variables, so collecting evidence about these variables. As soon as the loop ends, we check if we found an entropy value higher than 0. If we didn't, then it means that all the previous variables have been inspected, so everything is 0 as an entropy value, and we just need to, again, make a guess on the most probable variable. Sorry, the most probable value about W. Otherwise, we output the variable that is most convenient to investigate, the most entropic variable at the moment, together with a corresponding sentence. If we go back to the event graph, you can see that we use the same system, the synthesis system towards AWS Poly that is included in Fantasia to output the actual audio. Everything in here is just identical as in the basic tutorial, so I will not be going over it again. What's important here is this first part. So I slightly modified this. I'm using ASR only instead of natural language understanding, because in this example, JSON will be asking polar questions, so questions that either require a yes or a no. So no need to overshoot it with natural language understanding. As soon as the actual answer from me arrives from the transcriber, from the Azure transcriber, we check if we got a yes or a no, so if everything went fine with the transcriber. Again, this is simplifying things. And we check if we got a yes or a no. In this case, if we get a yes, then not a no will be a yes, we select this array of 2 elements by putting a 1 on the true value for the variable and a 0 on the false variable in the false value in the variable. So if we got a yes, we are certain that the value of the last variable that we inspected is true. Otherwise, the distribution will describe the opposite, so we are sure that the last variable that we inspected has a false value. We can then add evidence inside Unreal to the last variable inspected in the Bayesian network by passing these 2 elements in the array. And we can call again the generate sentence function, which will make a new inference, recompute the entropy of all the variables, and start all over again. So this is the basic cycle. JSON will keep asking questions about the parent variables of W until it has a low enough entropy, or until it is not able to ask anything more. When it goes asking about the parent variables, it will always select the most entropic node in the Bayesian network. It will get the most appropriate question to ask, and it will ask it. In this case, we just have yes, no as an answer, but you can go and complicate things as you want. So let's try our system here, and then let's see what happens.
Is it raining?
So the most useful thing for Jason now is to ask if it's raining. Now I'll give him an answer. Yes.
Is the sprinkler on?
So now he's asking if the sprinkler is on, and then I'll tell yes again. Yes.
The grass will be wet.
So in this case, Jason followed the strategy, simple strategy that we designed, asked two questions, got to yes, two times a yes, and now he's ready to take a stance about the fact that the grass will be wet. Let's run it again, and let's answer no to both questions.
Is it raining?
No.
Is the sprinkler on?
No.
The grass will be dry.
So in this case, he's also sure that the grass will be dry. As you can see, he's not asking about the sky being cloudy because he's very sure either in one sense or in the other. Let's see what happens if we mix the answers this time.
Is it raining?
Yes.
Is the sprinkler on?
No.
Is it cloudy?
Yes.
The grass will be wet.
As you can see, in this case, Jason was not sure enough about the stance to take about W, so he also asked a question about the sky being cloudy. This is a very basic example of what you can do inside Unreal with Bayesian networks to design decision systems that can guide a conversational agent. But of course, you can use Bayesian networks to take decisions about anything. In the next video, I will show you how to combine Bayesian networks more efficiently with the AI systems of Unreal.